question 11.103 says determine the pH for each of the following solutions. So I thought I could try A and C, and then we could answer 11.105 at the same time. Are these solutions acidic, basic, or neutral? So if we take a look at A, we are given the concentration of hydronium, which is 2.0 times 10 to the negative 8 molar, and we're asked to find the pH, and you might remember the formula pH is equal to the negative log times the concentration of hydronium. So this one's pretty straightforward. We just plug the numbers in. We get minus log of 2.0 times 10 to the negative 8. I'll leave out the units. And of course, when we punch that in our calculator, we get negative of negative 7.70. And we use two decimal places. So we have two decimal places here because we have two numbers or two significant figures in our mantissa. So let's see. So if I write down my final answer, so pH is going to be equal to 7.70. And if you remember the pH scale, that a pH of 7 is neutral, anything below that is acidic, and anything above that is basic. So therefore, since the pH is, we'll put here greater than 7, it is basic. Okay, so basic. If we take a look at B, so let's move on and take a look, or sorry, C. If we take a look at C, so we're given the concentration of hydroxide. So hydroxide, but the thing is that we want to apply our formula, pH is equal to minus log times the concentration of hydronium. So that doesn't really get us anywhere because we don't know the concentration of our hydronium. We're only given the concentration of our hydroxide. But luckily, we have a way to solve that by using Kw for the autoionization of water, which is equal to the concentration of hydronium times the concentration of hydroxide, and that's equal to 1 times 10 to the negative 14. So I can rearrange this formula to solve for H3O plus. So I can write H3O plus concentration is equal to Kw divided by the concentration of hydroxide. So if I plug in the numbers, I get 1 times 10 to the negative 14. We can assume an infinite number of significant figures here because the Kw is a constant, divided by our concentration of hydroxide, which is 3.5 times 10 to the negative 4. When you punch that in your calculator, you find out that the concentration of hydronium is actually 2.9 times 10 to the negative 11. So I'm just going to punch that number into my formula. pH is equal to minus log of H3O plus. So now I'm just using this formula up here. So I get minus log of 2.9 times 10 to the negative 11. And that tells me that my pH, when I put that in my calculator, is equal to the negative of negative 10.54. Again, applying the same rule with respect to significant figures. Since I have two numbers, two significant figures in my mantissa, that gives me two decimal places. So I can write down finally that my pH is equal to 10.54. And by the same rationale from the first question, when we had a pH above 7, this is going to be a basic solution. So hopefully you find this useful when you want to calculate not only the pH from the concentration of hydronium, but also the pH when you're given the concentration of hydroxide.